Hi, today we're going to do the second part of the benzoxazine experiment, which is the sodium borohydride reduction. Now you've used sodium borohydride before in the reduction of camphor experiment, but we're using it again as part of this three-step sequence. Now I literally just a few minutes ago made the imine. Here was some of the really pretty crystals that collected in the filter flask as the solvent evaporated. I wound up with about 2.25 grams of crude product from my Buchner funnel. So that is what I'm going to be using for the next step. I have 15 milliliters of methanol right here. I'm going to go ahead and dissolve up my stuff. So pouring in my methanol. Giving us, of course, our bright yellow mixture. I'm going to go ahead and stir that up on the stir plate. It's not all going to dissolve, but that's okay. Just going to get that good and mixed. The next item of business will be to cool this on an ice bath. I'm going to get that going, get it nice and cold, while I show you the equation for this reaction. So here's my ice bath. Get him nice and chilly. Okay, I'm going to turn the stirring back on. I apologize if the camera jumps around. Again, I'm doing this one-handed, so hopefully you can see what you need to. So I'm letting my solution get nice and cold. Here's the reaction. This is the imine that you made in the last step, or really the imine that I made that I wish you could have made. And we are using sodium borohydride. Of course, that's one of our hydride reducing agents. The hydride will attack the electrophilic carbon of the imine right here, adding a hydrogen, and then we will pick up a proton from the solvent methanol on our nitrogen, which is overall a net reduction. We end up with a hydrogen on the nitrogen. We already had this hydrogen from the imine, and then we have another hydrogen, which I didn't draw here, and I can't now that my hands are full, but there is a second hydrogen there as well. So we have added a hydrogen to both the carbonyl carbon that came from our original aldehyde and to our nitrogen. That is an overall reduction. So now we have our solution of our imine, and I have some sodium borohydride here, 0.3 grams of sodium borohydride. And I'm going to slowly add that to our solution. Now we talked in the last video about how the extended conjugation is what is responsible for this bright yellow color. So as you might imagine, as we break up that conjugation, we should lose the color. Let's see what happens. So I'm adding bit by bit my sodium borohydride. Get that right in the middle of the stir plate. Trying very hard to get my borohydride into the flask and not into the ice bath. Bit by bit by bit. Because this is really hard to do with a spatula one-handed, I'm going to pour the rest in from my weigh boat. If you were doing this for real, I would not have you do this because we do want a slow, controlled addition. But this is all about getting things done quickly, so we're doing what we can. So our color is starting to dissipate just a little bit. It's a lighter color than it was before. There's the rest of my borohydride. And look, most of our color has disappeared. I'm going to pick up the flask and swirl it a little bit. Make sure we get that good and mixed. We've added our borohydride, and there we have it. We are getting now a white solid. We still have some yellow on the sides, that's why I'm trying to swirl this around. So you can see that was pretty quickly, even at ice temperature. This was a fast reaction. It is exothermic, and at this point, most of our color has disappeared. So you can see some of the white solids starting to collect on the side of the flask. I'm going to go ahead and swirl one more time. So I'm just going to let that sit and stir for a little while until I collect it by filtration, and then we can get to our final step in this 3-step sequence to make a benzoxazine. I will see you later. Goodbye.